This tutorial is to show you a little bit of what Python programming can do in a Jupyter Notebook. So Jupyter is an open source application that operators can use to document and test programming code, write text explanations of procedures, and provide visuals of data in a variety of formats. In Jupyter, this is accomplished by these breaks. They're called cells, which you can change what type it is from this list. Both the heading and markdown cells can be formatted by font size, boldness, italics using a combination of special characters to highlight specific information. So here I've embedded an image of where I accessed the project data that's pulled into this notebook. So it's the familiar ArcGIS Online item details page. You can see down in the bottom right corner, if you click the view hyperlink, it will take you to this ArcGIS REST services directory where you can copy and paste the service item ID for each of the hosted feature services that we have in our project. Python has many built-in libraries, which are modules of pre-built code for many of the common actions that programmers use. Other open source libraries have been created for Python and can be imported into the notebook. We've done that here with a few. Esri's ArcGIS module lets us access our project data and display a map, and Pandas and ArcPy allows us to process large data sets faster, and we can provide visualizations for each cell that's executed. So this is just showing the copy and pasted item IDs from those REST services pages, and then we can direct Jupyter Notebooks to get those items and then display, which you see the thumbnail and some other information, and you can click and view that item details page from this section as well. So next, we add a map, and then all those different hosted feature services are added to the map. You have some of the same functionality as you do in the web maps. You can click on a point and get a pop-up, though unfortunately the custom configuration doesn't transfer over in the pop-up to the Jupyter Notebooks. As part of the FME Workbench workflow, I did download copies of all the filtered results, spatial and non-spatial, to another CSV file. So although the spatial results are limited, there are plenty of non-spatial tweets that fill these files, which creates an opportunity to study the topic content of the tweets themselves. So first we have a pandas table that's sorted by keyword, and then we also have the associated tweet for each of those keyword hits. If you see blue in the table, it is an active hyperlink which you can click and see what the image or video was that someone included in their tweet. So next we just take a look at the counts for each of the search keywords. So you have the values, and then we plotted it on a chart. So you can see the 5 different search keywords out of the original 9 that appear in this data set. Last in this look at the tweet content are some core statistics for each of the weeks. We see the count for the total tweets, which is 469 this week. There are 344 unique tweets, and then the top is the tweet that was repeated the most, and for frequency, that top tweet was retweeted 40 times. And we know it's a retweet because it starts with RT. So it's not an original post. So stakeholders interested in doing additional topic analysis might want to examine the content of those retweets and decide if they need to be in the data set or removed, which that decision would either be implemented here in Jupyter, or you can make updates to the FME workflow using another transformer to filter them out of the data set before you take a look at it. So I've jumped to the next week's core statistics, where you see the count went up to 1,242, although the uniques are only 752. This week encompassed election days, so many of the tweets are political in nature, which we can see with the top tweet, and that the frequency of the retweet was 157 times for that one unique tweet. So the text analysis for this notebook ends here, but there are many more options to further examine the data. Depending on what else you might want to know about your data, topic analysis could further break down each tweet. After some pre-processing, which would include removing all the special characters, common words, and capital letters, the common themes of each text could be sorted out to find similar words, the same words, and then those themes could better pinpoint events and opportunities that, say, the anti-litter groups could go to and focus educational activities. To finish off this Jupyter Notebook sample, the data sources and other resources have been documented with hyperlinks for more information. There are many options to share a Jupyter Notebook, which commonly the notebook is shared by this file, and in our case a PDF was created so that it could be added to our ArcGIS online gallery that has all our project components. Jupyter Notebooks is a really powerful tool, and this is just a brief and simple sample of some of its vast functionality. Anyone more adept at Python could easily turn this data into so much more with minimal effort.